Dear students, under the topic angle of intersection of two curves in polar coordinates, here we have the second problem. Show that the parabolas are equal to a secant square theta by 2 and are equal to b cosecant square theta by 2 intersect at right angles. So we have to show that the angle between these two parabolas is 90 degrees. That is pi by 2 in radians. So let us see the proof now. So first step is let xi denote the angle of intersection of the given two curves. So if xi is the angle between the two curves, then xi will be equal to phi 1 minus phi 2. So what is phi 1 and phi 2? Phi 1 denotes the angle between the radius vector and the tangent at the point of intersection for the first curve, and phi 2 denotes the angle between the radius vector and the tangent at the point of intersection for the second curve. So to find the angle between the radius vector and the tangent, we have already learnt in our previous video lectures. We shall use those concepts here in order to find phi 1 and phi 2. And we can subtract one from the other and we can consider the absolute value for the angle of intersection of the given two curves. So let us see how to find phi 1 and phi 2 for the given two curves. As the first step, let us mark the given curves as equation 1 and equation 2, where equation 1 represents curve 1 and equation 2 represents curve 2. So I have taken r equal to a secant squared theta by 2 as equation 1. Now differentiating equation 1 with respect to theta, what we get is, so the differentiation of r with respect to theta is dr by d theta, and that is equal to, a is a constant, so a multiplied with secant squared theta by 2. So the differentiation of secant square, so first we have to differentiate the square term, that is 2 secant theta by 2, and then we have to use the chain rule method and differentiate secant theta by 2. What is the differentiation of secant theta by 2? It is secant theta by 2 tan theta by 2 by using the differential formula, one of the formulas of differentiation. And then we have to use the chain rule method and differentiate theta by 2. The differentiation of theta is 1 and by 2 will be 1 by 2. So therefore differentiation of equation 1 is dr by d theta is equal to, a is a constant, so we should first write as it is, multiplied with secant squared theta by 2 we have here. So we have to differentiate for the square term first. So by using x power n formula, we know that it is nx power n minus 1. So here n is 2. So 2 and secant theta by 2. This is raised to the power 2 minus 1, which is 1. So we are not writing 1 here because we know that it is secant theta by 2. And multiplied with the differentiation of secant theta by 2 is secant theta by 2 tan theta by 2, and multiplied with the differentiation of theta by 2 is 1 by 2. So these are the two formulas that we have used. So I have listed it here. So next step is dr by d theta will be equal to, now this 2 and this 2 will get cancelled because this is in the denominator and this is in the numerator, and a is a constant which will come as it is, and the secant theta by 2 gets multiplied with secant theta by 2 and it becomes secant squared theta by 2, and then we have tan theta by 2. So let me write that here. Next step is we have to find phi 1, for which we have to find tan phi 1, which is equal to r multiplied with d theta by dr. So we shall substitute each one here and evaluate. What is r? R is the given curve, that is a secant squared theta by 2. So therefore we can substitute that here. So tan phi 1 will be equal to, so r is a secant squared theta by 2. So a secant squared theta by 2. multiplied with d theta by dr is the reciprocal of dr by d theta. So reciprocal, so we have to take 1 by of this value. So 1 divided by a secant squared theta by 2 tan theta by 2. So if we see, a and a gets cancelled, and also secant squared theta by 2 and secant squared theta by 2, which is in the denominator, gets cancelled. And what is 1 by tan theta by 2? It is cot theta by 2. So tan phi 1 is equal to cot theta by 2 is what we have obtained. So now here we are going to use a formula. So let me list it out. First we used 1 by tan. So we know that 1 by tan theta is equal to cot theta. So using this formula we have obtained this value. So this is done. Next we are going to use here, that is tan 90 minus theta. So 90 can be written as pi by 2. So tan pi by 2 minus theta will be equal to cot theta. So this is a formula. So using this we can say that cot theta by 2 can be written as tan pi by 2 minus, because theta, instead of theta we are having theta by 2, it will be tan pi by 2 minus theta by 2. So we can replace cot theta by 2 as tan pi by 2 minus theta by 2. So therefore we obtain tan phi 1 to be equal to tan pi by 2 minus theta by 2. Now comparing the left and the right, we can say that the angles are equal. Or taking tan inverse on both the sides, we get phi 1 to be equal to pi by 2 minus theta by 2. So we have evaluated phi 1. The next step is we have to evaluate phi 2, for which we have to consider the curve 2. So let us see that now. So now we have considered the curve 2, r equal to b cosecant squared theta by 2, and we have marked it as equation 2. So let us differentiate this equation with respect to theta. So when we differentiate this with respect to theta, what we get is dr by d theta is equal to, b is a constant, multiplied with, again use the formula x power n, which will be nx power n minus 1. So here it will be 2 cosecant theta by 2 multiplied with the differentiation of cosecant theta by 2, which is negative cosecant theta by 2 cot theta by 2 multiplied with the differentiation of theta by 2, which is 1 by 2. So here we have used the formula, differentiation of cosecant theta is minus cosecant theta cot theta. So that formula we have used and we have done the differentiation. So these are the two formulas that we have used. So I have listed out here. So now if you see, this 2 and this 2 gets cancelled, and we get dr by d theta to be equal to, so b multiplied with, when this cosecant theta by 2 gets multiplied with this, we get cosecant squared theta by 2, and this negative sign we can write in the front. So it will be minus b cosecant squared theta by 2 cot theta by 2. So kindly write theta by 2 here. So cot theta by 2. So after this, the next step will be to find the angle phi 2. So tan phi 2 will be equal to r multiplied with d theta by dr. So we shall substitute each one over here. So what is r? R is equal to b cosecant squared theta by 2. So when we substitute that here, we get b cosecant squared theta by 2 multiplied with, what is d theta by dr? It is the reciprocal of this value. So it will be 1 by of this value. So it will be because we have a minus sign, it will be minus 1 by b cosecant squared theta by 2 cot theta by 2. So now if you see, b and b gets cancelled, and cosecant squared theta by 2 and this cosecant squared theta by 2 gets cancelled, and so we are left out with tan phi 2 is equal to, we have this negative sign, so minus, and what is 1 by cot? 1 by cot of an angle is tan. So minus tan theta by 2. So now here we can use a formula, that is tan of minus theta will be equal to minus tan theta. So we can use this here. That is, we have minus tan theta by 2 here. So what is minus tan theta? It is tan of minus theta. So this can be written as tan of minus, instead of theta what we have here? We have theta by 2. So minus tan theta by 2 can be written as tan of minus theta by 2. So therefore we get tan phi 2 to be equal to tan of minus theta by 2. Now equating the angles on both the sides, we get phi 2 to be equal to minus theta by 2. So this is the value of phi 2. Already we have obtained the value of phi 1 as pi by 2 minus theta by 2. So now we have these two values. So using these two values we can evaluate xi, which is given by the absolute value of phi 1 minus phi 2. So that will be equal to, so xi will be equal to, what is phi 1? We shall substitute this. So pi by 2 minus theta by 2. And what is phi 2? Minus theta by 2. So minus of minus will become plus. So plus theta by 2, because it is phi 1, okay, minus phi 2. So minus of minus will become plus. And this will get cancelled and we will be left out with pi by 2. But what is pi by 2? It is 90 degrees. So therefore we have obtained xi to be 90 degrees, that is pi by 2. And what is xi? Xi is the angle of intersection between the two curves. So therefore the angle of intersection of the two curves is equal to pi by 2, which is 90 degrees, and hence the given two parabolas cut each other orthogonally. So therefore we have proved that the given parabolas intersect at right angles, hence shown. So I hope you have understood this problem. See you with a similar kind of problem in our next video. Thank you.